This video is about determining if triangles are similar. So there are three methods to prove that triangles are similar. There's angle-angle similarity, side-angle similarity, and side-side-side similarity. So in order for triangles to be congruent using angle-angle similarity, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So in this picture, we have that A is congruent to D because they have the same markings, and we know that B is congruent to E because they also have the same markings. So now that we have two angles from each triangle that are congruent, we can say that triangle ABC is similar to triangle DEF by angle-angle similarity. The second method is side-side-side similarity. So in side-side-side similarity, if three sets of sides of the triangle are proportional to three sets of the corresponding sides of the triangle, then the triangles are similar. So when we're trying to figure out if they're similar, we want to figure out sides that are going to match up and maybe reduce to the same ratio. So in this case, I'm going to use 3 over 6, which reduces to 1/2, 4 over 8, which reduces to 1/2, and 6 over 12, which reduces to 1/2. So because they all reduce to the same fraction, the triangles are similar. So when we name the first triangle, we can name it any way we want. So I'm going to say triangle ABC is similar to, and this is where we have to be careful. So we said that BC was 6, it matched up with the DE side, and then BC was 3, and it matches up with the EF side. So our last letter is F. So triangle ABC is similar to triangle DEF by side-side-side similarity. The last type of similarity then is side-angle side. So in side-angle side, it's going to have one set of angles that are congruent and then two sets of proportional sides that are touching the angle. So basically the sides that form that angle. So in this case, we have that angle A is congruent to angle D. We're going to see that 3 over 9 reduces to 1/3. And 4 over 12 also reduces to 1/3. So we do have two sets of sides that are proportional. So we can say triangle ABC is similar to triangle DEF by side-angle side similarity. Explain why the triangles are similar and then write a similarity statement. So in this case, in number 1, we already know that P and Q are similar because they have the same right angle marking. We also know that we have a triangle, the big triangle, and then a little triangle inside. Notice that those two triangles share an angle. And remember, when something is shared among the triangles, that's the reflexive property. So by the reflexive property, we know that R is congruent to itself. So we can say that these triangles are similar because we can say that P is congruent to Q because they are both marked as right angles. Angle R is congruent to angle R by reflexive property. So now that we know we have our two angles, we can say that the triangles are similar. So I'm going to name the big triangle first. So triangle PRT is similar to triangle QRS by angle-angle similarity. Number 2. So number 2 is a bow tie problem. Remember in bow tie problems that we always have vertical angles are congruent? If I want to, I can even number them as 1 and 2. I also see that HL and JK both have an arrow, which means the lines are parallel. So if I use those parallel lines and pick a transversal, I can say that H and K are congruent because they are alternate interior angles. So now when we explain, we would say that angle 1 is congruent to angle 2 because vertical angles are congruent. And then we could say that angle H is congruent to angle K because alternate interior angles are congruent when lines are parallel. Now, notice that we have two sets of congruent angles again, so now we know our triangles are congruent. So we can say that triangle HLI is similar to triangle KJI by angle-angle similarity. Number 3 is another bow tie problem. So we know in a bow tie problem that again our vertical angles are congruent. So we have 1 and 2 congruent. We also need to show that our sides are proportional. Remember, when you're doing a bow tie problem, the sides that correspond with each other are from the same line. So we need to show that 12 over 10 and 18 over 15 reduce to the same thing. So 12 over 10 reduces to 6 over 5, and 18 over 15 reduces to 6 over 5. So in this case, we would say that angle 1 is congruent to angle 2 because vertical angles are congruent. And then we would also name our sides. So we can say that MN over NP and QN over NO are proportional. We showed that with our math up here, so now we can say that our triangles are similar. So we have triangle MQN is similar to triangle PON by side angle side similarity. Number 4, we need to see that all the sides are marked with numbers, so we need to show that they're proportional. So when we're trying to figure out if they're proportional or not, try to look and see which numbers are going to have a relationship with each other. So I'm going to put the smallest side over the smallest side, the middle over the middle, and the largest over the largest, and see if they all reduce to the same thing. So we have 4 over 8, which reduces to 1/2. 5 over 10, which reduces to 1/2, and 6 over 12, which reduces to 1/2. So because they all reduce to the same ratio, we can say that JK over TV, JK over VU, and LK over TU are proportional. So then we could say that triangle JLK is similar to triangle. Now here's where we gotta be careful. So JL is the side with the 4, and then it's going to our largest side. So we want VTU because VT goes to the largest side of the other triangle by side, side, side similarity. Number 5. So number 5, we have two triangles that we're going to look at. We have this triangle right here, and then we also have this triangle right here. Our big triangle. So notice that between the pink and the blue triangle, that angle S is a shared angle, so it's congruent by reflexive property, and we already have that N and O are marked as congruent angles, so those triangles would be similar. So in our explanation, we would say that triangle O is congruent to angle O by given, and angle S is congruent to angle S by the reflexive property. So now that we know that, we can name our triangle. So I'm going to name the small triangle SNW is similar to SON. And remember that these N's are different because the N in the first one is talking about the little n, and the N in the second one is talking about this whole angle. By angle-angle similarity. Number 6. So in number 6, we have two triangles, and we know that ABCD is congruent to itself because it's an angle shared in the little and the big triangle. We also see that LK and FE are parallel, so we know that L and F are congruent because those are corresponding angles. So in this case, we would say that A is congruent to A by the reflexive property. And then we would also say that angle L is congruent to angle F because corresponding angles are congruent when lines are parallel. So number 7, SNW is similar to triangle FLK. Solve for x and y and state the scale factor. So in this case, we know that SN is the first two letters and it matches up with side FL. We know that NW is the second and third letter, so it matches up with LK. And we know that our longest side is SW, the first and last letter, and it matches up with FK. So now we're going to solve for x and y. So I see that 20 and 12 have numbers on both of those sides. So we're going to use 20 over 12 twice to solve for x and y. So to solve for x, I see that x matches up with the 15. So we're going to have x over 15. And remember that the same numbers from the same triangle need to go in the same part of the ratio. So now I can cross multiply and I get 12x is equal to 300. And when I divide by 12, I get that x is 25. And we're going to do the same thing to solve for y. So 35 and y are on the same sides of the triangle. So we have 20 over 12 equals 35 over y. When I cross multiply, 20y is equal to 420. When we divide by 20, we get that y is 21. So, and the last thing they want us to do is find the scale factor. So remember, for scale factor, it's always your new shape over your old shape. So we're going to use the sides that already have the numbers, the 12 and the 20. So I would have new over old, 12 over 20, which reduces to 3/5. Number 8, given that triangle ABC is similar to triangle PQR, AB is 2x, AC is x plus 10, PR is 3x plus 6, and PQ is 6x minus 16. Find the measure of x and identify the scale factor. So we're going to draw two triangles. So we have triangle ABC, and we have triangle PQR. So AB is 2x, AC is x plus 10, PR is 3x plus 6, and PQ is 6x minus 16. So when I look at my picture, I know that AB matches up with PQ because they're the first two letters of the triangles. And I know that AC matches up with PR because they're the first and last letter of the triangle. So now we can set up a proportion. So I'm going to have 2x over 6x minus 16 is equal to x plus 10 over 3x plus 6. So when we go to cross multiply, we get 2x times 3x plus 6 and 6x minus 16 times x plus 10. So on the left-hand side, I'm going to distribute the 2x to both terms, and I get 6x squared plus 12x equals, and I'm going to distribute over here, so 6x times x is 6x squared. 6x times 10 is 60x. Negative 16 times x is negative 16x. And negative 16 times 10 is negative 160. So when I combine like terms, I get 6x squared plus 12x equals 6x squared plus 44x equal or minus 160. Well, I notice that there's a 6x on both sides, so when I subtract 6x, those cancel out, and I'm left with 12x equals 44x minus 160. So I want to get my x to the other side, so I'm going to subtract 44, and I get negative 32x is equal to negative 160. When we divide, we get that x is 5. Now that I know x is 5, I need to substitute in order to get my scale factor. So I'm going to substitute into the yellow side. So 2 times 5 is 10, and 6 times 5 minus 16 is 14. So remember that your scale factor is your new shape over your old shape. So PQR is the new shape, ABC is the old shape. So we have 14 over 10, which reduces to 7/5. Number 9, ABC has the coordinates A 0, 0, B negative 9, 6, C 3, 6. Dilate with the center at the origin of the scale factor of 1/3. So first I'm going to draw this picture. So I have A is at 0, 0, B is at negative 9, 6, and C is at 3, 6. So I have my first triangle. Then I'm going to dilate by multiplying by a scale factor of 1/3. So when I multiply by a scale factor of 1/3, 1/3 of negative 9 is negative 3. 1/3 of 6 is 2. So that's going to be point D. When I multiply by 1/3 here, 1/3 of 3 is 1, and 1/3 of 6 is 2. So that's going to be point E. So D is at negative 3, 2. E is at 1, 2. Now, I need to prove that they are similar. So to know that they are similar, I know that A is congruent to itself because it's an angle in both triangles. So by reflexive property, it's congruent. So we can start by saying A is congruent to angle A by the reflexive property. Then we need one more set of angles. So we know that B has to be parallel to D because they're horizontal lines. So now we're going to say that BC is parallel to DE because horizontal lines are parallel. So now, because we have those parallel lines, we can pick which one we want to use. So I'm going to say that B is congruent to D because they are corresponding angles. So we would have that angle B is congruent to angle D because corresponding angles are congruent when lines are parallel. So then to end this, we would say that triangle ABC is similar to triangle ADE.